I'm Anil Kumar. Here is an application question on operations with monomials. The question is, square is inscribed in a semicircle. Find the ratio of the diameter of the semicircle to the side length of the square. You can pause the video, answer the question, and then look into my suggestions. So let me sketch one. This diagram will represent the situations. Let's say this is our semicircle, right? So let's make a semicircle. Okay, kind of, not bad. Okay. So semicircle, let's say this is the center. So one square is inscribed in it. So let's say that is the square. Doesn't quite look like, okay. Okay, so what we will do is we'll assume that all sides are equal, okay. It's more of a rectangle anyway. So the diagram really is not representing a square, it represents a diagonal. Let me sketch another one, okay. So we'll sketch this time kind of like this. So if that is the, okay, so that works better, okay, that's fine. So this looks more like a square, okay. So we'll work with this diagram. Okay, fine, we'll create another problem with this rectangle for you. Right, so what we have here is a semicircle and a square. And what we need to find is the ratio of diameter of the semicircle, that means from here to here, to the length of the sides, to this length of the side of a square, or you could say this length, right? This length. So that is the question for you. Okay. Now let us see how to solve it. Since the diagram is there, I think it may be simpler for you to visualize and solve. So take a shot at it. Okay. Here is how I will do it. Let me do some more construction here. Let's say this is the center of the semicircle, and that becomes the radius. So that is the radius for me. Let me call this R. And let us say that the length of the square is 2x, so that half is x. So we'll keep this as x and we'll write this as 2x. Okay. So now what we are saying is find the ratio of diameter of circle. So we need to find diameter of circle to the side length, to side length of square. So this is what we need to find. Now clearly, if R is the radius, then diameter is 2R, correct? So from here we know one thing. If let's do the work here. If R is radius, then 2R is diameter. Correct. So diameter is 2R for us. And the side length we have taken as 2x. Well, that really doesn't help since we have two different variables and we don't know exactly how to relate them. To relate these two variables, what can we do? Let's look into this triangle once again. We see that this is kind of a right triangle, right? It will always be a right triangle. Now, in this right triangle, let's label this as O, A and B. So, in this right triangle, we have 90 degrees at B. So these two legs, sum of squares of these two legs should be equal to the square of the hypotenuse, correct? So that is the relation which relates x with r. So now we can write x square plus 2x whole square equals to r square. You get an idea, right? Now x square plus 2x whole square is 5x square is r square, and from here we can write what r is in terms of x. So if we square root it, let me push it a bit so that's clear to you. If we square root it, we get square root of 5 times x. We could write x, kind of here better, equals to r. So now we get a relation between these two variables, right? So what we have written here is that r, the relation which we found, is r equals to x times square root of 5. Since r is x times square root of 5, we can write it in this particular equation, which is simplified as r over x. So r is x times square root of 5 divided by x. And now we can cancel out x, right? And simplify it as equal to square root of 5. Do you see that? So the ratio of diameter of a circle is indeed equal to square root of 5. So that is how you can actually solve such a question. I hope that helps. So the concept here is to visualize and then solve the question, correct? Now I'd like you to do the same question. Let me change the values, which kind of I sketched earlier. If we have, instead of a square inscribed, now let me write down a new question for you. Question number 2. If we have a rectangle with side ratio 1:2. Let's say we have a rectangle with side ratio 1:2 inscribed in a semicircle. Right, so instead of a square, if we have a rectangle with side ratio 1:2 inscribed in a semicircle, as I've drawn earlier, in that case, you need to find ratio of area. So find ratio of area of semicircle to that of rectangle. So I've changed the question a bit just to go with the sketch which I've drawn earlier. And that's a question, a practice question for you. If we inscribe a rectangle within a semicircle with side length ratio 1:2, then what is the ratio of area of semicircle to that of the rectangle? I'm Anil Kumar, and I hope this basic concept helps you to develop methods of solving similar questions. Thank you and all the best.